This assignment was called Write, Solve, and Graph Equations. And for this one, you have some questions that are multi-part and you have some questions where you're graphing on a graph. So if you're not sure how to answer something or if it's being counted as incorrect and you feel like you've done it correctly, don't be afraid to reach out to me or one of your other teachers to ask questions about what's going on. We're just going to work the odd problems on this one. So question number 1, this is a two-parter, so just because we answer the first part doesn't mean that we're done. A ball is dropped from different heights. The table shows the height of the first bounce after the ball is dropped. So when you drop it from 10 inches, it bounces back up 5 inches. When you drop it from 20 inches, it bounces back up 10 inches. Drop it from 30 inches, bounces back up 15 inches. So something that you need to know about this table is that this is your X and this is your Y. The height that it bounces depends on the height that you dropped it from. Okay, so part A says, using the data from the table, which equation can be used to find y, the height of the first bounce in inches, when the ball is dropped from a height of x inches? So let me zoom out a little bit so we can see all of that. So we can just plug in the numbers from the table into the equation to see if they make sense. So this one, y equals 2x, is y equals 2 times x. So is 2 times 10 5? No. So it can't be that. This is y equals x divided by 2. Is 10 divided by 2 5? Yes. So the answer for part A is B. Can't be C, can't be D. And you can check it. Is 5 times 10 5? No, absolutely not. Is 10 divided by 5 5? No. So the only answer that makes sense is B. Let me see if I can show the tables. I think they're front and back, so that's going to be a little tricky. So for part B, it says to select the graph that shows the relationship between the height of the height from which the ball is dropped, X, and the height of the first bounce, which is Y. So remember that horizontal is your x-axis, and there's our x right there. Vertical is your y-axis, there's our y right there. So we said that the formula that was correct was y equals x divided by 2. So if I do 50 divided by 2, do I get 25? Is 50 divided by 2, 25. Oops, yeah, that was right. And then boom and boom. So yes, 50 divided by 2 is 25, so that one checks out. Is 100 divided by 2 50? It is. You should know that one. If you don't, you can work it out, but that one should be one that you know. So the answer has to be A. You can check the other ones on your own. Okay, moving on to number 3 now. If you're stuck on number 2 is a lot like the previous worksheet that we did, solve real-world problems using equations. It's going to be set up similarly to that, so you can use that video to help you with number 2 if you're stuck. All right, number 3. A train was traveling at a constant speed. The table below shows the distance in miles the train traveled for the first 4 hours. So in 1 hour, they traveled 95 miles. In 2 hours, they traveled 190 miles. In 3 hours, they traveled 285 miles. And in 4 hours, they traveled 380 miles. So the time that they traveled and the distance that they traveled, the distance depends on how long they were traveling. Time is almost always an independent variable, not 100% of the time, but most of the time. So I want to kind of find out how much we're going up by here. So I'm just going to see, let's see what happens. 190 minus 95. Okay. Can't take 5 away from 0. So I go over here to make that an 8 so that that can become a 10. Can't take 9 away from 8. So I go from here to make that a 0 so that can become an 18. So that went up from here to here by 95. So this was plus 95. And just doing a little bit of head math, this one's also going up by 95. And yes, this one's also going up by 95. Okay, so we know that each of these is increasing 95. So that makes sense. If I'm traveling for 1 hour at 95 miles per hour, then if I'm traveling 2 hours, obviously it's going to be double that. 3 hours is obviously going to be triple that. 4 hours is obviously going to be quadruple that. So write an equation to represent the relationship between t, the time, and d, the total distance. So they want us to use t and d instead of x and y. So the distance depends on the time traveled. The distance depends on the time traveled. Now, each of these is going up by 95, so the time is being multiplied by 95. D equals 95t. Okay. The graph below shows the relationship between t and d for a trip that lasted from 0 to 7 hours. That I don't think is correct because I only see up to 4. But that's really not the important part because this next part wouldn't be on the table anyway. If a train was traveling nonstop, how many miles would it travel in 5.5 hours or 5 5/10 hours? So what I would need to do is substitute my time, which is 5.5 for t. So I would be doing 95 times 5.5, but I'm going to write it as 55 for right now. 5 times 5 is 25. 5 times 9 is 45, 46, 47. Placeholder 0, done with that, done with that. 5 times 5 is 25. 5 times 9 is 45, 46, 47. 5 and 0 make 5. 7 and 5 make 12. 1 and 4 make 5. 5 and 7 make 12. 1 and 4 make 5. So then, remember there was a decimal right here, so there was one number behind the decimal in the problem, so there needs to be one number behind the decimal in my answer. They are going to travel 522 5/10 miles. Okay, for the last one, and I'm not going to do this with you because this one's really easy. You're just graphing this formula right here. T equals 2C. So the C is the cupcakes and the T is the cost. Each cupcake costs $2. And so you're going to find out if I bought 0 cupcakes, I'm going to spend $0. If I bought 1 cupcake, I'm going to spend $2. And you're just going to keep graphing like that. So this is 0.1. Okay, go ahead and finish that. And if it's counting anything wrong, show it to me or one of your other teachers and we'll figure out what's going on together.